Hi everyone. I'm giving the tutorial for IndicXlit model, as in like how to download, how to use the IndicXlit model using command line interface, Python interface, how to train it from scratch, and how to fine tune the model using our IndicXlit pre-trained model. So yeah, let's get started. Here we are installing the FAIRSEQ. FAIRSEQ is a sequence-to-sequence library for transformer-based models and for NLP and speech. So here is a bunch of installation command that we have to use it to install the FAIR sequence. Then we are setting up the FAIR sequence path, the environment and variable. Yeah, then we are setting up the command line interface directory to install and download the models and re-ranking dictionaries in that. Yeah, then here we have already made more models and dictionaries available on the GitHub, so you can directly download using these links and unzip it. These are the models and these are the dictionaries for re-ranking option. Yeah. So it's fairly simple. Just you have to create two directories. This is the input directory and the output directory, and we have to create a file. We have to create a file like contains a list of words, and format should be a space separated Roman characters in each line. You can see the file. File should look like this, and there's a one over yeah, we've wrapped the model files and Python files and pre-processing stuff in one bash file. So here you have to just call that file and give bunch of inputs. So first one is the language code, in which language you want to translate it. These are the languages we are supporting. This is the name of the input file, beam size, and this is the number of candidates you want it in output. So re-ranking option, either it could be 1 or 0. Yeah, that's for running the yeah, command line interface, and you will this final transliteration.txt file will get stored in the output directory, and these are our outputs. So this is it for command line interface. So this is we also prepared for Python interface. We can, yeah, we had created a Python library which is a wrapper around IndicXlit model. So you can directly install with pip command, pip install for Bharat transliteration, and just import the XLit engine class. Uh, it's also fairly simple, and here we are just calling the class and creating an object, uh, and passing the language code in it, whichever the languages we want to initialize the model with. So this command will initialize the model, a multilingual model that supports all the languages. So it will load a single model, and it will load all the dictionaries which we are passing in this argument. So here it will load a Hindi dictionary into the RAM. Also passing beam size and rescore option. And yeah, after initializing the model, we just have to call this function using this object, translate word, and pass the word, and it will get transliterated as many candidates you want. Also, if you want to again transliterate some other word, then you just directly call this function again. It will not initialize the model again. So that is the advantage of Python interface over command line interface. Yeah, this is the example without using rescoring option as using rescoring option as false. We can also transliterate sentence. So just pass the sentence here and it will get transliterated. Yeah. Also, if you want to initialize the model with the multiple languages, you can directly pass a list of languages here, and it will load all the dictionaries of languages you have passed in list in the RAM at the same time. So when you call this function, you just have to pass the word. You don't have to initialize the model for each language again, and it will give the output as it is, like ML is for Malayalam and TA for Tamil, and both the outputs will be in list. So yeah, and last thing, if you don't pass any language code, it will by default load all the languages. So be cautious about it, because it would require 8 to 10 GB of space in RAM. So dictionaries are itself 7 to 8 GB. Yeah, that is it for Python interface. Yeah, let's go over how to train your model from scratch, how to train transliteration model from scratch. So yeah, again a bunch of installation command. We have to set up a parsec environment in the background. Um Set up the environmental path, and here we are setting up the all the training and IndicXlit folder. Just yeah, for re-ranking option, we are downloading all the dictionaries. Yeah, here we are taking a toy example of dictionary dataset for training. So we're downloading and unzipping it. Okay, so now there is some specific format required for use this training procedure. So first we create the corpus, and we put all the training files in this format. Train dot like train underscore bn dot bn and train underscore bn dot en, for like two files for each language. To train for training files. So, and the format would be same as we have seen earlier, like list of words with space separated Roman characters in each line, and that corresponding word pair, like whatever the corresponding word is there in the other language, should be in train x dot x file, like train bn dot bn file. So yeah, we also have to create one combined training file across all the languages. It is train combined.cmv. This bharat, right? So it would be like bha, aki matra, ra, space aki matra, ra. Yeah, each character and each vowels, and we are breaking. Yeah, so yeah, this is kind of simple Python file which is creating test file, validation file, and train file into the specific format. And here we are just combining across all the languages. Yeah, so for that combined file, we need for vocab creation. So this is the parsec preprocess command which create the vocabulary. We are just passing the combined file, and it will create the vocabulary. Then using those vocabulary, we need to binarize all the file for each of the languages, for each of like training file, validation file, and testing file. This every file will get stored in this destination directory corpus bin. And also there is one explicit requirement is to store all the list of language command into one file, and we have to store that file in the same directory. So yeah, I put it in a bash way, but yeah, you can directly list all the commands and save it in the same directory. Okay, so this is the training command, parsec train. We just have to pass this corpus bin directory, binarized corpus directory as an input also, and have to specify in which directory we want to store the model. So these are all the parsec arguments. Like if you want to get into detail, you just can directly refer to this parsec documentation. And if you want to learn specific about this translation multi-simple epoch task, it is a multilingual training with temperature sampling option. So you could just go over here and learn about it. So yeah, that's it for a training command. Like it will train the model, and it will store the model in a transformer directory. So along with this many checkpoint will be stored in this directory. You can use the best one uh, when you generate the result or evaluate the model. So yeah, this is the generation command. Again, parsec generate. You can pass the corpus bin directory in which we have all binarized test and validation file. You can yeah, give the model path here. Again, specify the task and a bunch of parsec arguments. Yeah, and it will store this farsec output in this output directory. So okay, now if you want to evaluate the model and get the exact accuracy numbers and everything, we have code four evaluation matrices in the evaluation result series core option file, Python file. But for that, we need to post process some farsec output and get it stored in some XML format. So this is a simple XML, like this is converting farsec output into the XML format file, XML files. So again, I just put the all the coding details of this file into the cell itself. But yeah, like further we will just give the this file as a, you can directly download it as a directly download it and give the input as a separate file. And yeah, you can directly run the Python command for that. Okay, now for calculating the metrics for evaluation, you can just directly download this evaluation file. We had made it available on the GitHub, and run this Python command. It will give a bunch of evaluation matrices on the result we get. So this is the word level accuracy. It will be only true when the exact word will like ground truth will match with the exit prediction. This is the F score and character accuracy. All is there. Okay. This is it for training the model with Scratch. So now let's go on fine tuning the model. Yeah, same. We need to install the fair sequence in the background. Again, setting up the environmental variable of farsec path on the environmental variable, setting up the directory for fine tuning, and downloading the IndicXlit model. Like these are the pre-trained IndicXlit model. You can directly download it from GitHub, and then yeah, this is the command for downloading the dictionaries, pre-ranking option. Again, we are taking the toy example of Dakshina dataset for fine tuning. So downloading and unzipping it. Also, we have to prepare the corpus for it. So it's the same format we discussed on the training file. Just create the corpus directory, and here only difference is we don't create the combined file across all the languages, because we don't need to create the joint vocabulary. So this code is commented here, and this joint vocabulary will come along with this IndicXlit model file, so we can directly use it here and binarize all the like training, validation, and test file for each of the language here. So this is a farsec preprocess command. Yeah, again we have to store all the language codes in one file to like whichever the model supports. Here we have listed 22 Indian languages. So EN is one, and other 21 Indian languages with whichever model supports. For training, so okay, for fine tuning, again we can use this farsec train command here. So this four bunch of arguments are different from what we have used in training file. Same, we have to give input as a corpus, binarized corpus directory. This is a saving directory where we want to store the models. These are all training arguments, and here we are passing the IndicXlit model, like a pre-trained IndicXlit model. Can reset the scheduler and all, and we can again train from that checkpoint. Like continue training from that checkpoint. So the new fine-tuned model will get stored in this transformer directory. Again this check, like use the best checkpoint, and generate the output as we have done in the training file. This is also the same file. So this output result generation and evaluation file is same as what we have done in training. Now we can calculate the accuracies. Okay, so this is it. Like we have prepared all the notebooks. These are all the notebooks we prepared, and one more thing I would like to show is we have also hosted our models on Ulka. So yeah, and all 2021 transliteration model is available on Ulka. And if you want a quick demo, you can go here and just type the word in whichever language you like. Here is a language option. We can select any language, and as you type the word, it will suggest some suggestions, and you can select among that. So you can directly use this notebook training from scratch. So when we are loading the like all the files in corpus, here we are separating each of like as I was said, like we have to make the list of words in this format. So here instead of this, you can you can have the character separated for Urdu, and like word for Urdu, and as according to Hindi in the corresponding file. You can use the same format, uh, prepare the corpus as in we have prepared for Bengali to English, and yeah, same you can prepare the joint. You don't have to prepare the joint vocab. So here you directly run this farsec preprocess command. You don't have to you don't need a multilingual model. You can train bilingual model as in Urdu to Hindi. You just need one command farsec preprocess. This will create the vocabulary as well as the binary as well as the binary files for testing and validation. And yeah, also you don't need this setup putting all the languages in the language list. So it's a fairly for bilingual model is a fairly three simple commands: farsec preprocess, that what I've shown you, and this is the farsec train model, farsec train command. And you don't have to pass this task. Instead, you can pass. As far as I remember, it's a machine translation task. So it will do the job, and some argument will change for bilingual model. Okay, I can quickly show you which which two commands you have to use for training the model. This is the farsec preprocess command that you can use for binarizing file, and also to create the vocabulary. And this is the farsec train command. You can refer to this first link. You don't have to go through this second link. This is the specific to translation multi-symbol epoch task. So these all the arguments are specific to this task, but you can use a machine translation task instead, and you can use this command and train the model directly. So it will be a bilingual model, and that will do the job.
So thank you everyone for joining for this session. Of course, the discussions can go on, and I'm sure once you start using all the stuff that we spoke about today, you might have more questions. So feel free to write back to us. You can follow our GitHub pages, raise issues there, and we'll respond to that. Thank you.